This is an educational documentary about the history of technology and biography. The content covers weapons development in a strictly historical and educational way. In 1916, while soldiers were dying by the thousands in the trenches of World War I, an American mechanic had an idea the generals called insane. He wanted to turn a hunting rifle into an automatic combat weapon. The military laughed. Experts said it could not be done. But John Browning was about to make the most lethal weapon of the 20th century, a machine gun that would change how wars were fought forever. This is the story of the man who dared to challenge the impossible. John Moses Browning was born in 1855 in Ogden, Utah, into a family filled with gun-making and metalwork. His father, Jonathan Browning, was a pioneer gunsmith who made rifles for settlers and hunters in the American West. The family workshop was attached to their house, and the smell of gun oil and metal filings was part of John's childhood. At 7 years old, while other children played, John was already at the workbench watching his father. He saw how metal bent with heat, how parts fitted together with millimeter precision, and how a simple mechanism could release a controlled explosive force. To him, weapons were not only instruments of death, they were mechanical puzzles to solve. At 13, John built his first complete rifle using only scrap metal from the workshop. It was not only functional, it outperformed many commercial rifles of the time. His father recognized immediately that the boy had extraordinary talent. It was not just hand skill. John could picture complex mechanisms in his mind, see how forces moved through gears and springs, and predict how parts would behave under stress. The Browning family was Mormon, and their faith shaped John's character. He grew up with values of hard work, persistence, and a belief that God gives people gifts to help humanity. John believed his mechanical talent had a higher purpose. When he was 19, his father died suddenly. John took over the family workshop with his brothers. It soon became clear he was more than a gunsmith. He was a natural inventor. While other gunsmiths copied designs, John started to rethink how guns worked. In 1879, he patented his first single-action rifle. It was revolutionary, simpler, more reliable, and more accurate than anything else on the market. The Winchester Repeating Arms Company, one of America's largest firearms makers, immediately bought the patent. That was the start of a partnership that lasted decades. Over the next years, John created a long list of innovations. He developed repeating rifles, pump-action shotguns, and semi-automatic pistols. Each design broke technical barriers other engineers thought impossible. European manufacturers studied his work with envy. Hunters and competitive shooters wanted his weapons. But John had one obsession: to build a true automatic weapon, a gun that could fire continuously as long as the trigger was held. This idea fascinated him not from a desire to destroy, but for the technical challenge. How could the energy of a shot be used to eject the empty case, load a new round, and fire again? How to control recoil? How to stop overheating or jamming? At the time, the military was not very interested. Automatic guns existed, like the Maxim, but they were huge, heavy, complex, and very expensive. Nobody believed an automatic weapon could be practical on the battlefield. John Browning was about to prove them wrong. One ordinary summer day in 1890, John Browning was at a shooting range testing a new rifle. Each shot made a cloud of hot gas escape the barrel after the bullet left. John watched these gases carefully, as he always did. For him, every shot was an experiment in applied physics. Then something happened that would change firearms history. As he fired near the ground, John noticed the exhaust gases moving the grass beside the rifle. The vegetation bent violently from the invisible force of the gases. Shooters had seen this many times, but no one had looked at it with the eyes of an inventor. John stood still, watching. His mind raced. Those gases had power, wasted power, released into the air with every shot. What if that energy could be captured? What if it could be used to operate the gun itself? He rushed back to his workshop with an excitement his brothers immediately recognized. When John had that look, it meant he had imagined something revolutionary. For weeks, he made sketches and calculations. He needed a system to channel the gases from the shot to drive a piston. The piston would eject the empty case, feed a new round from the belt, and ready the gun for the next shot, all automatically. In theory, it was simple. In practice, it was extremely hard. The pressures were enormous, and the timing had to be perfect. If the system opened too early, the gas would escape and there would be not enough force. If it opened too late, the pressure would damage parts. Heat made another problem. Hot metal expands and changes its properties. John began building prototypes. The first exploded on the bench. The second jammed after 3 shots. The third ran for 20 shots before a spring broke. Each failure taught him something. John did not see failure. He saw data. He changed dimensions by fractions of a millimeter, tried different metals, and adjusted spring angles and tensions. His brothers sometimes questioned whether the effort was worth it. Winchester already bought his conventional rifle designs, and they made money. Why risk everything on a wild idea for an automatic weapon nobody asked for? But John was driven by more than profit. He needed to solve the problem. He was sure it was possible, even when others said it was not. He had seen the grass move and knew he had discovered a basic principle no one else had. After months of obsessive work, he finally had a working prototype, a gas-operated machine gun capable of continuous fire. He tested it in secret, firing hundreds of rounds without stopping. The weapon heated up, but did not fail. The mechanism worked like a Swiss watch, even under extreme stress. John knew he had made something special, but he did not yet know that that moment watching the grass would lead to the most influential weapon in modern military history. In 1891, John Browning presented his new automatic machine gun to the United States Army. He was sure it was technically superior to anything else. It was simpler than the Maxim, lighter, and more reliable. He had solved problems other engineers thought were impossible. The demonstration was held at a military base in front of high-ranking officers. John carefully prepared the weapon, loaded the ammunition belt, and began the test. The machine gun roared, firing with impressive accuracy and speed. Empty shells flew through the air. The target down the field was destroyed in seconds. When silence returned, John expected applause. Instead, he saw skeptical faces and little interest. One general said the weapon was a technical curiosity, but had no real use. Another claimed machine guns were only for fortresses, not field battles. A third officer simply said the Army already had Maxim guns and didn't need a replacement. John was confused. He explained the advantages. Fewer moving parts meant fewer failures. The gun was lighter and easier to carry, and its gas system was more efficient than the Maxim's recoil system. But every argument was met with polite rejection. The truth was, in 1891, the military still thought in 19th century terms. They believed battles were decided by infantry in formation, firing in volleys. Machine guns were seen only as defensive tools, not weapons that could change the nature of war. Frustrated but not defeated, John returned to Ogden. He knew his invention was revolutionary. If the American military didn't see it, he would find another way. He showed the weapon to private companies and foreign officers. Some were interested, but none wanted to fund large-scale production. For years, John kept refining the design while working on other inventions to support himself. During this time, he created the famous Colt M1911 pistol, later the U.S. Army's standard sidearm for 70 years. He also made new shotguns and rifles. Yet the automatic machine gun remained his true passion. What John couldn't predict was how quickly the world would change. In Europe, tensions were rising. Empires armed themselves, nationalism grew stronger, and alliances formed. It was a pressure cooker waiting to explode. In 1914, the assassination of an Austro-Hungarian archduke in Sarajevo lit the fuse. Within weeks, the major powers of Europe were at war. World War I had begun, and with it came trench warfare, a new and brutal kind of combat. Millions of soldiers dug trenches and faced each other across open fields covered with barbed wire. Between them lay no man's land, mud, craters, and death. Old military tactics collapsed. Generals ordered charges where thousands of men ran into machine gun fire. It was mass slaughter. At the Battle of the Somme, the British lost 60,000 men in a single day, most to machine guns. The Maxim and similar guns were deadly but flawed. They were heavy, needed 4 to 6 men to carry, were fixed to tripods, overheated quickly, and required water cooling systems. They also had hundreds of delicate parts that jammed easily in mud. The U.S. Army watched Europe's war with concern. By 1917, when America joined, it was clear they needed machine guns, and fast. But they had only a few hundred Maxims, far too few for an army of millions. That's when officials remembered the Utah inventor who had demonstrated such a weapon years earlier. John Browning, now 62, was called to Washington. This time, the generals weren't doubtful. They were desperate. The reports from the trenches were horrific. They needed better weapons immediately. John didn't bring one design. He brought two. The first was an improved version of his original gas-operated machine gun. The second was entirely new, a heavy, water-cooled machine gun powered not by gases but by recoil. Each shot pushed the barrel back slightly, cycling the weapon automatically. The demonstrations were spectacular. Browning's heavy machine gun fired for minutes without jamming. It was simpler than the Maxim, with only 40 major parts compared to the Maxim's 200. It could be built faster, and it was more reliable in harsh conditions. The officers were impressed. But there was one big problem: time. Factories had to be built, workers trained, tools made, and supply chains organized. This would take months, while soldiers were already dying in France. Every delay cost lives. At an age when most men would retire, John Browning entered the most demanding phase of his life. He worked 18 hours a day overseeing production, solving factory problems, and training army gunsmiths. His weapon had to be perfect, and it had to reach the front fast. The race against time had begun. The most fascinating part of Browning's design was its unlikely origin. While most military engineers started with battlefield requirements and built weapons from scratch, John had done the opposite. His core ideas came from hunting. Hunting weapons had to be accurate, durable, and reliable in harsh natural conditions. John had spent decades designing rifles and shotguns for hunters. These guns had to work flawlessly in the freezing mountains, the damp forests, and the dusty deserts. A hunter's survival could depend on a single shot. One failure could mean losing food for weeks. This demand for absolute reliability shaped Browning's entire design philosophy. When he noticed the gases moving the grass that day in 1890, he was testing a hunting rifle. The realization that wasted energy could be captured and reused did not come from a laboratory, but from a simple shooting range. It was the kind of breakthrough only someone who understood weapons at the deepest level could make. For Browning, they were not just tools of war, but precision machines. The gas-operated system he created was elegantly simple. A small hole in the barrel allowed part of the gas from the shot to be redirected into a cylinder. That gas pushed a piston, which moved the bolt. The bolt ejected the empty cartridge, compressed the return spring, and was pushed forward again by the spring, loading a fresh round. The entire cycle happened in fractions of a second. But simple did not mean easy. Every part had to be engineered with extreme precision. The amount of gas diverted had to be exact. Too little and the gun would not function. Too much and the parts would wear out. The timing had to be flawless, so the bolt would not open while dangerous pressure was still inside the barrel. Materials had to withstand intense heat and repeated stress. John tested dozens of setups, different gas port sizes, piston lengths, and spring tensions. Each prototype was fired thousands of times until something failed. Then he studied the failure, found the weakness, and created a fix. Out of these years of experiments came a design that was surprisingly advanced. The system was self-regulating. If pressure was too high, the piston moved faster, but the recoil absorbed the extra force. If pressure was too low, the system still worked, just more slowly. This gave the gun reliability even with poor quality ammunition or extreme conditions. Another brilliant feature was ease of maintenance. The weapon could be completely taken apart in minutes without special tools. Soldiers could replace parts themselves. This was revolutionary. Earlier machine guns required trained specialists for even small repairs. Browning had turned the principles of hunting weapons into tools of war, but the ultimate test remained. Would it work in the brutal conditions of Europe's trenches? When the U.S. Army approved Browning's machine guns in 1917, a great invention had to be matched by a miracle of industrial production. Tens of thousands of complex weapons had to be built in just months, a massive challenge for American industry. The top priority was the M1917 heavy machine gun based on Browning's recoil-operated design. It had 40 major parts, each needing to be made with extreme accuracy. Even a variation of 1/10 of a millimeter could turn a reliable gun into one that jammed. The U.S. government mobilized industry like never before. Automobile plants were turned into gun factories. Machine tool companies built new specialized equipment. Metallurgy companies developed stronger alloys for the stresses of constant fire. It became a national effort. John Browning was at the center of it all. He traveled constantly between factories, fixing production problems. If workers struggled with a part, John redesigned it to be easier to make without losing function. If materials failed, he found alternatives. If testers reported issues, he solved them immediately. One of the hardest challenges was standardization. Unlike commercial products, every military weapon had to be interchangeable. A gun made in Ohio had to work perfectly with parts made in Connecticut. That required strict quality control and consistent manufacturing. Colt's Patent Firearms Company led the effort. Workers labored in 3 shifts around the clock. Women entered the factories in large numbers, running machines and checking parts with great precision. Many became highly skilled, producing components as accurate as the most experienced men. Every gun was tested extensively. Thousands of rounds fired under mud, sand, water, and extreme temperatures. Failures were disassembled, studied, and improved. It was a constant cycle of refinement. At the same time, production of the lighter Browning automatic rifle, BAR, accelerated. This weapon was groundbreaking. It was light enough for one soldier to carry, yet had the firepower of an automatic weapon. It was essentially the first modern assault rifle, though the term didn't exist yet. Within months, American factories were making hundreds of guns each day. Special trains carried them to ports, where ships took them to France. Each crate represented thousands of hours of design, engineering, and labor, and carried the hope that it could tip the balance of war. The first M1917s reached France in early 1918. American soldiers, many new to combat, were trained quickly. Instructors showed how Browning's design could be taken apart, cleaned, and put back together in minutes. Troops were impressed by how intuitive and dependable it was. The true test came during the German spring offensive of 1918. Knowing that fresh American forces were arriving, German troops launched a massive attack to win before the balance shifted. Waves of soldiers advanced across no man's land. For the first time, Browning's M1917s roared in battle. The sound was different from the Maxim, deeper and steadier. With a rate of 400-600 rounds per minute, the guns laid down curtains of bullets that shredded anything in their path. Soldiers watched in awe as the guns fired continuously without jamming. What truly set the M1917 apart was its reliability under extreme conditions. Trenches were a nightmare for any machine. Mud, humidity, sudden temperature changes, dust, and dirt creeping into every mechanism. Maxim machine guns often jammed and needed constant cleaning. The M1917 kept running. Field reports impressed commanders. One gun fired 20,000 rounds in a single day of combat, stopping only briefly to change its overheated barrel. Another was buried by an artillery blast, dug out, cleaned quickly, and put back into service within minutes. Even guns that had fallen into mud puddles were shaken off, cleaned of their main parts, and kept firing. The bar, Browning's lighter version, was equally revolutionary. Soldiers could now carry automatic fire with them instead of relying only on fixed trench guns. This transformed infantry tactics. Assault teams used the bar to lay down suppressing fire while others advanced. It was a completely new style of mobile combat. The Germans quickly realized something had changed. Their intelligence reports noted the new American machine guns were unusually reliable. Captured soldiers admitted that while their MG-08s were excellent, they were harder to maintain in the field. Browning's designs gave the Americans a clear technical edge, but it wasn't only about specifications. It was also psychological. Soldiers with M1917s or bars trusted their weapons. They knew the guns would fire when needed. That confidence boosted their performance. Commanders, too, could plan knowing automatic firepower would be available without fail. In September 1918, during the Meuse-Argonne offensive, Browning machine guns were deployed in large numbers. They played a vital role in breaking through German defenses. The combined roar of hundreds of M1917s filled the battlefield with a deafening wall of sound. By the armistice in November 1918, Browning's guns had proven themselves beyond doubt. But their story was only beginning. The end of World War I confirmed them as the global standard. Armies everywhere studied them with admiration. Browning's designs had set a new bar for automatic weapons. The M1917 became the U.S. Army's standard heavy machine gun for decades. The bar had an equally strong legacy. It was adopted by over 20 countries. Variants were used in hunting and law enforcement. In Prohibition-era America, both police and gangsters carried bars, their automatic fire making them infamous in urban shootouts. Even after his triumph in World War I, Browning never stopped. In his 60s, when most men retired, his creativity was still alive. He designed new pistols, innovative hunting rifles, and kept improving his machine guns. In 1921, while working in Herstal, Belgium, with arms manufacturer F.N. Herstal on a new pistol design, he suffered chest pains. True to his character, he kept working at his bench, but the heart attack was fatal. John Moses Browning died at his workbench at the age of 66, surrounded by the tools and projects he loved. News spread across the world. Newspapers praised him as the greatest weapons inventor who ever lived. Soldiers and officers from many nations paid tribute. But his real legacy lived on in the decades that followed, as his designs continued to shape modern warfare. Between the wars, Browning's guns were steadily improved. Engineers made small changes after years of use. Better metals and manufacturing techniques were introduced, but the core design stayed the same. In 1933, the legendary M2 was born, a 50-caliber version of Browning's heavy machine gun. It could penetrate light armor and bring down aircraft. The M2 combined massive power with Browning's trademark reliability. It became his most enduring legacy, staying in active service for over 90 years, a record almost unmatched in military history. As war clouds gathered over Europe in the 1930s, armies everywhere prepared frantically. In arsenals across dozens of nations, Browning's machine guns were pulled from storage, cleaned, tested, and readied for another global conflict. The Utah mechanic, long dead, was about to shape yet another world war. When World War II erupted in 1939, Browning's weapons were present in nearly every theater. The M1919, a lighter, portable version of the M1917, was mounted on vehicles, aircraft, and infantry positions. The part of 50-caliber M2 became universal, fitted to tanks, jeeps, ships, planes, and fortifications. Unlike World War I's static trenches, World War II was a war of movement. Tanks thundered across fields, aircraft dominated the skies, and Marines stormed Pacific beaches. Browning's machine guns had to work in every environment. In the deserts of North Africa, fine sand clogged delicate German MG-34s and MG-42s. The Brownings kept firing. British and American soldiers developed near-religious faith in their reliability. Tank commanders especially loved the M2. It could shoot down aircraft, smash fortified positions, and pierce lightly armored vehicles. In the Pacific, the bar became the squad's automatic weapon of choice. On Guadalcanal, Iwo Jima, and Okinawa, the bar's firepower often meant the difference between victory and retreat. American bomber crews relied completely on Browning, 50 caliber guns for defense. B-17 flying fortresses carried up to 13 of them. When German fighters attacked, the sky lit up with red tracers. Gunners swung their turrets in deadly arcs, firing thousands of rounds per mission. A jammed gun could mean death. Reliability wasn't just a technical advantage, it was survival. Production soared. American factories built more than 2 million Browning machine guns during the war. Women filled factory floors, machining precision parts and assembling weapons with speed and skill. By 1945, the U.S. had created the greatest industrial military machine in history. Other weapons were retired after the war, but Browning's guns endured. In Korea, in the 1950s, soldiers used the same M1919s their fathers had carried in World War II. In Vietnam, the M2 was still the main heavy machine gun, now mounted on helicopters as well as ground vehicles. The remarkable thing was not just longevity, but continued superiority. Engineers tried repeatedly to replace Browning's designs. Prototypes were tested, contracts were signed, new weapons were even adopted. But again and again, soldiers in the field chose the old Brownings. The M2, especially, proved irreplaceable. Even in the Middle East wars of the 1990s and 2000s, more than 80 years after John Browning first noticed grass move from rifle gases, his guns were still in combat. In Afghanistan and Iraq, M2s were mounted on Humvees and forward bases. The weapon that had defended bombers over Europe was now fighting insurgents in desert valleys. The story of John Moses Browning is bigger than one inventor's biography. It is the story of how one man's genius and determination reshaped history. His weapons influenced the great conflicts of the 20th century and remain relevant in the 21st. The 50 caliber M2 is still in service in more than 100 countries. No other firearm in history has matched its record. Since 1933, it has served for more than 90 years without interruption. Modern engineers with computers, advanced alloys, and generations of research have never built a weapon fundamentally better. The gas-operated principle Browning discovered by watching grass bend became the foundation for most modern automatic weapons. The American M16, the Russian AK-47, and countless others are direct heirs of Browning's insight. He didn't just invent guns, he discovered principles that defined an entire field of technology. Beyond the patents and blueprints lies something deeper, the nature of true innovation. John Browning had no formal engineering degree. He never attended university. He lacked laboratories or research teams. What he had was careful observation, endless creativity, and the persistence to test an idea until it worked. His design philosophy was simple. Use the fewest moving parts, harness natural forces instead of resisting them, and build tolerance into systems so they worked even as parts wore down. Ideas that seem obvious now were revolutionary then. Browning registered 128 patents in his lifetime. He designed pistols, rifles, shotguns, machine guns, and even cannons. Many are still made today. His Browning high-power pistol, finished after his death by protégé Dieudonné Save, was adopted by over 50 armies worldwide. There is irony in his legacy. John Browning was a peaceful, deeply religious man who believed his gifts should serve humanity. Yet his most famous creations were weapons of war. Millions have died from designs he created. He never spoke publicly of regret, but it is hard to believe he never thought about the consequences. Perhaps the best way to understand Browning is as a problem solver. He saw mechanical challenges and could not resist fixing them. That his solutions were used for war was not his intent, but a result of the violent times he lived in. Had he been born in another era, perhaps his genius would have shaped farming tools or industrial machines. The humble mechanic who once transformed a hunting rifle into a weapon of legend never thought himself special. To him, it was just work. Yet his work changed the world more than he could ever have imagined. Over a century later, John Moses Browning's legacy is still alive in the sound of machine guns that continue to echo across battlefields.